All right, we are recording. Hello, everyone. Welcome to the day 2 of our Forge online training event. My name is Petr Broz. I'm a Forge developer advocate. And today, again, I'm joined by my colleague Deepali, who will be helping answering your questions during our sessions today. If you have any questions, throughout our presentation, feel free to ask them using the Q&A feature in the Zoom toolbar that hopefully you all see. And Deepali will can answer some of those as I'm demoing. And then at the beginning of each session, we will review any pending questions and discuss them before we move on to the next step. All right. For those of you who maybe are joining us for the first time today, maybe some of you were not able to join the day 1 sessions. This event is basically our way of helping those of the customers who prefer to have a little bit more live guidance when following our tutorials. So we have different sorts of learning resources. One of them is this learnforge.autodesk.io website. Which I think is pretty self-explanatory, but again, we understand that sometimes people prefer they can see or have a bit more, again, guided tour through a tutorial. So that's why we're running this event where we actually show you how you can follow these tutorials, how you can build your Forge applications step by step, always, giving you time to follow up after, each session. So again, this is a 4-day event. Today we're on day 2, and each day we are running 2 parallel tracks for Node.js and .NET, depending on what language you prefer. We run these 2 languages in parallel for the European audience, that's right now, and then we're also running these same parallel tracks for Node.js and .NET for the American audience. That will be starting in about 8 hours from now. During each session, during each day, we run 4 sessions. Each session is roughly 30 minutes long. That's where we explain part of a tutorial, some of the steps needed there. We show you how to do those, and then you have roughly one hour and a half to follow these steps as well. And then later, 2 hours later, we meet again for the next session, and we repeat that. And this is how we proceed throughout the day until you get to having a complete Forge application running. All right. The topic for today is building an application that can access your existing designs in one of the Autodesk applications that are already built on top of Forge. That's applications such as A360 or BIM 360, BIM 360 Docs, or Fusion Team. All right, that is our topic for day 2. This is what we're going to build. It's going to be a simple web application, quite similar to the one that was built during day 1. But this time, instead of adding a UI where you can create buckets and upload files and translate them, here we will actually we will provide a login functionality where our users, where the visitors of our web app will be able to log in with their Autodesk credentials. And after logging in successfully, they'll be able to navigate their existing designs in different products. Again, that could be in A360 or BIM 360 or Fusion Team. All those are basically Autodesk products that have been built with Forge, right? And Forge, when you build your own application using the Forge platform, Forge gives you access to your users' content in these other Forge applications as well. That's what we're going to be working on today. And how will the sessions look like? Right now, we're going to take a look at, again, basic introduction and setup of our environment and provisioning the application, right? There's going to be one important step that needs to be done if you actually want your Forge app to have access to, let's say, your users' BIM 360 documents. In the next session, we're going to start implementing basic server-side logic using Node.js, and we will add some important endpoints for this login workflow. There are a couple of steps that need to be taken when your user wants to log in. So we're going to cover that in session 2. Session 3 will be used to implement the server-side logic for actually listing the content. So that's listing the different projects or products like A360 or Fusion Team or Bin 360, and listing the folders, subfolders, items, and versions. All of that will be covered in session 3. Again, it's all going to be server-side logic, preparation for the final session, session 4, where we're going to implement the client side. Again, it's going to be a simple HTML with a little bit of CSS and a little bit of JavaScript that'll be used to populate the sidebar, the tree, with your folders, files, and versions. And then, of course, the Forge viewer that will load and show whichever document you selected from the tree. All right, so on to session 1. Same as during day 1, what we would ask you to do before we move on to the actual implementation is making sure that you have a Forge account with a Forge subscription. It can be a trial one. And second, that you have a Forge application. And again, very quickly, for those of you who are here with us for the first time, a Forge application is basically a collection of credentials, sort of like your application's username and password, that you're going to be using when communicating with the Forge platform. And one very important piece for today, specific to our application that we're building today, it's important to also have some kind of data, again, in one of the existing products, Autodesk products built with Forge, so that is BIM 360 or A360 or Fusion Team. And if you do want to try access your content in BIM 360, there is one important step. It's called provisioning. So for A360, this is not necessary, but for BIM 360, if your Forge app wants to access your user's data in BIM 360, you actually need to whitelist your application in BIM 360. This is an additional security measure that the BIM 360 product has, right? So BIM 360 will not allow your custom Forge application to access its data unless you, as an admin of your BIM 360 project, add it to the list of allowed applications. So that's an important step for those of you who want to really, again, who want to access BIM 360 content. For now, again, as a fallback, a backup plan for those of you who maybe are not admins of BIM 360, because in that case, you'll probably need to contact someone who is an administrator of your BIM 360 project and ask them to provision your application. But if you will not be able to do that for today, don't worry. We can still use A360 again as a, as another product that we will be accessing our designs from today. And for development, just like during day 1, we will be using Node.js runtime. So one thing that we ask you to make sure of is that you have Node.js installed on your system, that you have some kind of a terminal, either Bash or a terminal, standard terminal on Unix-like systems, or command prompt on Windows. Or on Windows, you can also get something like Bash with when you install Git, right? The source code management tool that comes with something called Git Bash that you can use as well when working on Windows. So just make sure you have Node.js long-term support version installed. That's the version 14, and make sure that in the command prompt or terminal that you have access to. You can call the commands called node and npm, right? The node package manager. That's what we're going to be using for initializing our project and installing, managing dependencies. And for the editor, you're free to use whichever editor you want. We will be using the Visual Studio Code. All right, time for a demo. So first of all, again, make sure that you have access to the Forge portal and that you have some Forge subscription. for example, the trial subscription. If you don't have one, just use the sign up to try Forge button on the front page of forge.autodesk.com. Otherwise, you can just log in, as I will do here. All right. And we're in. So now what will happen is when you log in, you'll have access to your applications under your icon, your avatar in the top right corner. When you go to My Apps, you'll see maybe a collection of some existing apps. You may not have any applications here. You can see I have plenty of those because, again, I typically create different Forge apps or credentials for different customers so that their data is siloed, right? So that one customer does not have access to data of another customer. And if you don't have a Forge app yet, you can create one here using this Create App button. By the way, if you already have your application that you used for day one, for example, you can definitely reuse that one. But here, again, just for those, in case anyone here is joining us for the first time, I'm just going to create another app just for demonstration. And again, if you're creating an application, you'll be asked to select which APIs, which services you actually want to use. I would just recommend choosing everything, even if you're not planning on using all of them today. There's nothing, I don't really think there's any reason for not selecting any of these. So leave all the APIs selected and provide some name for your app. So I'm going to call it Forge Online Training App, training April 2021, day 2. I'm going to add some description, view your models in A360, 360, and Fusion Team. All right. And this time, these two fields, again, are required. Yesterday, we didn't care about those too much, but today we will. Callback URL basically is the address where your users will be redirected to after they log in, right? So today, we're going to be adding this login functionality to our app. And what that means is there's going to be a button called login, let's say. And when the user clicks that button, they'll be redirected to Autodesk sign in form. That's going to be a completely different URL, right? Where they're going to be able to log in, enter their username and password. And if they log in successfully, Autodesk will need to redirect them back to somewhere, right? Ideally back to our own application. That's the URL that we will need to specify here. Now, for now, we can set it to any arbitrary address. We can change it later, but I will already add this in because I know that we're going to be testing our application locally, so it's going to be running on localhost 3000, right? And I kind of already remember. Again, we can change that later. That the URL that we will be building in our server logic that will be used to handle this callback from Autodesk. This redirection from Autodesk servers is going to be API Forge OAuth callback. And again, don't worry if you don't have to memorize this. We can get to this later. We can update the callback URL later when we actually implement the server-side logic for this endpoint. And I'm just going to say localhost is our. Let's see if it won't let me. So there are some requirements, like it has to be a valid domain. So I'm going to call it localhost.com. Maybe that will work. Or all right, localhost.com. And this one doesn't have to be a valid address for the website URL. All right, and our application is now created. And we have our two important values, the client ID and client secret. And again, those are sort of your application's username and password. We will be using them when setting up and configuring our application. These are the values we'll be using when we actually try and communicate with Forge from our code. All right, that is for our application. Now, the third part was making sure that we have some kind of content in, let's say, in A360 or BIM 360, right? So in my case, what I'm going to do, go to a360.autodesk.com and sign in. All right. So I'm here, and you see I already have a couple of projects in well, actually Fusion Team now. Again, I can see if there's anything I can maybe reuse later. Okay, yeah, there it is. So, okay, so I'm going to be maybe, I'm going to be accessing this project and these files later on in my application. For you, for the purpose of testing your application today, I'd recommend either try the BIM 360 approach, and I'll explain shortly how to provision your app if you do have BIM 360, or just go to a360.autodesk.com like I did. And if you don't have anything here, any content, you should be able to just create a new project, empty project, and upload some files, right? Some testing files. If you don't have any design files of your own, you can just search for, let's say, Revit samples. I believe that should be sufficient. Revit sample project files, so you can download some Revit files from there. Or if you look for maybe Inventor samples, you'll find some sample Inventor assemblies there as well that you can upload to A360 to have some testing designs here that we will be accessing with our application later today, right? That's for those of you who don't have or who are not interested in accessing BIM 360. Now, if you are interested in accessing BIM 360, let me just go back to the portal. That's the forge.autodesk.com website, and go to documentation and BIM 360. Right, so BIM 360 API is one of the services available in Forge. This one specifically allows you accessing and managing your content in existing BIM 360 projects. If you look at into the developer's guide, I believe, was it here or was it, oh, sorry, step-by-step tutorials and getting started. Here, this will be important for those of you who do want to access their BIM 360 content. And I was sending out this, oh, Deepali?
Oh, that was my mistake.
You're raising it, all right. So I think I was sending out the information to, or adding this information to the blog post when announcing this Forge Online training event. But if you haven't done that, that's fine. We should still be able to get you up and running so that later today you can access your BIM 360 documents. First of all, you'll want to have access to a BIM 360 account. There are a couple of options. You can use this, follow this link to try BIM 360 for free. But what's really important is that if you want to access your BIM 360 content from your Forge app, the BIM 360 project or account needs to be switched to a developer account. This is the one piece that may take a little bit, but I'm hoping that I'm hoping that you'd be able to get answer from this email soon. So basically, if you have a BIM 360 account, you're an admin, send an email to this email address and to have it switched to a developer account, because only after that, you will be able to access this specific UI in BIM 360 admin interface to add your own Forge application as the custom integration. And that is actually explained in the second step of getting started, is manage API access to BIM 360 docs, right? So once you've sent your email to that address to ask to have your BIM 360 account switched to a developer account, you can then head over to your admin interface of your BIM 360 account, and you will then see this custom integrations tab under settings, right? Otherwise, if this is not a developer account, this item will not be available. It will only appear after your BIM 360 account is switched to developer account. And then this is where you can actually add custom integration and add your Forge client ID. And by that, basically whitelisting that app saying, yes, that Forge application with that client ID can definitely access the content in this BIM 360 project. So you'll say add custom integration, and as a developer. And here, this is the important piece. This is where you'll copy and paste the client ID of your app, of your Forge application that we have just created, right? That's the part where we're whitelisting and saying, okay, this app can access the user's data in this BIM 360 project. And that's it. All right, so that's, again, for those of you who want to try accessing BIM 360 content. I'm not sure if I have access to a BIM 360 project, but we'll actually see that, right, as soon as we start building our application and asking Forge, hey, give me the list of all the products and different products that this user has access to, right? And then Forge will tell me, okay, this user, Peter, has access to A360 projects, this and that. And then it'll maybe tell me, this user has also access to BIM 360 projects, this and that. So we'll see that later. All right, that's for the environment. Again, Forge application, well, Forge account, Forge application, and access to A360 or BIM 360 Fusion team. And for the development tools and environments, again, we're going to be using Node.js long-term support version. That is the version 14. So please make sure that you have 14.something version installed on your system and that you can call node and npm on your machine. So in my case, if I try and call node, it does exist. If I check the version, it's version 14.15, and I can also call npm, that's the node package manager. So I can do things like npm install to install dependencies or npm init to create a new Node.js project. That's for the programming language or language runtime. And for the editor, again, we're going to be using Visual Studio Code. That's the small, lightweight version of Visual Studio that I think is really great for web development. So if you want to give it a try, just head over to code.visualstudio.com, download the stable build and install it. And again, I'm not sure if we need to repeat the Forge extension. I'm thinking most of you probably were with us during day one, so you know how to get that set up. But again, if there's somebody else who didn't join us for day one, let me know, because if you're interested, there is a special extension for this editor that we have developed that gives you access to your Forge content and to different Forge services. So if there are any of you who are interested in getting that set up, let me know and I can quickly cover that maybe at the beginning of the next session. All right. Now it's your turn. So again, make sure you have access to Forge. You have, let's say, the trial subscription. Make sure you have some kind of Forge application with client ID and client secret, these two important values. And then check and maybe prepare some designs in Fusion Team A360, or maybe take a look at BIM 360. If you already have an existing BIM 360 project and you're an admin, go through the steps explained on the Forge portal, right? In the BIM 360 APIs step-by-step tutorials to make sure that, again, you have your BIM 360 account switched to developer account and that you added your Forge application's client ID as another custom integration in the admin interface under settings and custom integrations. That's the piece that will be needed if you want to be able to see your documents from your custom app. Otherwise, the BIM 360 project will not appear on the list when you're asking Forge. And for development runtime, again, make sure you get the Node.js long-term support version 14 installed, and that you can run the node and npm commands from either a terminal or command prompt on your system. All right, now let's see if there are any questions or comments. See in the chats. Mitchell, don't worry. We're happy to have you. All right. So question number one. So is the Forge client ID asked during the custom integration the same as the app client ID from my apps? Exactly. Yes. Yes. Let me just quickly recap that. So let's say if I wanted to, again, I don't think I'm an admin in any of my BIM 360 projects. So unfortunately, I cannot show you this interface live, but yes, absolutely. If you want to add a custom integration, what you would want to do when you get to this interface, add custom integration, it'll be asking you for Forge client ID, right? This long, weird string. And that is exactly the string you see when you go to your apps, your Forge apps. So I would basically just go and copy this client ID and paste it there. All right, and one more question. When I change client ID and secret in the Forge extension in VS Code, should the buckets change? Because they aren't in my case. All right, so that's a question specific to the VS Code extension. So if I understood it correctly, what you did is you went to the settings. Oh, maybe try the other way. So you're using the extension 401. I forgot that I regenerated the client secret for my app yesterday. So let me go where? So my application from day one and copy the new client secret. And again, for those of you who are here for the first time, you're going to see, of course, the client secret in here as I'm going to be pasting it or adding it to the, using it in different places, but you definitely don't want to share the client secret with anyone. It's like, again, your password. So, all right, I see somebody raised a hand. If you have any question, please again, feel free to either comment in the chat or ask in the Q&A. Or if you need to chat, I think we can give you a mic of audio as well. So what you don't want to share the client secret with anyone, right? Here in my case, I will need to expose the secret because I'm going to be using it in different parts of the demo. But what I'm going to do after the demo, I'm going to click this regenerate button to basically have a new password or new secret created for my app. So the one that was visible will not be valid anymore. Let me go back to my settings in VS Code. So if I understand it correctly, you changed your credential, like client ID and client secret. But then when you go back to your app, to your extension, you still see the same buckets. I think that may be because changing the values here does not automatically refresh the extension. So I think what you'll need to do is when you change your client ID and client secret, just use maybe the, what's it called, command palette, and find the command called developer reload window. This will basically reload the entire VS Code. It's kind of like basically restarting it. And when you do that, the extension, the VS Code extension for Forge is going to be initialized again, right? And then you should see new buckets, or then you should see the content from the newly configured client ID and client secret. All right. Awesome. So no other questions. Though again, there was one person raising hand, but I don't see other questions or comments. So it looks like we're good, and we're exactly at 30 minutes mark. Perfect. All right, so your turn now. I will pause the recording. All right. Hello, everyone. Welcome back to session 2 of our topic today, which is building Forge applications for accessing your content, your designs in BIM 360, Fusion Team, or other applications built on top of Forge. Before we move on to the implementation of this step, let's give a little bit more time to any additional questions. We've answered your questions you posted up until now, but if there are any other questions, anybody ran into any problems, let us know. Now's the time. Again, one topic that was repeated in the questions was what to do if I want to make sure that my Forge application can access BIM 360 designs, right? Documents in BIM 360. For that, again, what I'd recommend doing is, first of all, heading over to the Forge portal, to forge.autodesk.com, and to the documentation section. This is where you'll find the documentation and tutorials and getting started and references for all the different services that make up the Autodesk Forge portfolio. And in here, head over to BIM 360. This is a documentation section for the BIM 360 service that's part of Forge, the service that allows you to actually access and manipulate your content in the BIM 360 product. If you head over to either Developer's Guide or the API reference, you can find this Getting Started tutorial under step-by-step tutorials. And this is where you'll find information about how you can, first of all, get access to a BIM 360 product if you don't have one yet. And more importantly, in the second step, how to provision your application, your custom Forge application, so that it can access your users' content in the BIM 360 product. This is the important page. So manage API access to BIM 360 services. And again, what you'll need is either you or someone you know with admin privileges for your BIM 360 account. So you'll want to make sure that, well, first of all, also to send an email that is mentioned in the first step here, BIM 360 apps activations at autodesk.com. You'll want to send an email to this address to ask to have your BIM 360 account switched to a developer account. Because only then, when you log in as an admin and when you enter the admin interface of BIM 360, only then you'll see under the settings section, and you'll see this custom integrations link, right? And that's where you'll be able to add a custom integration for your specific Forge app, or you paste the client ID from your Forge application into this pop-up or modal dialog, this one, and the name of your app, right? And by saving this custom integration, again, you'll be able to, your Forge app will be able to access the content of that BIM 360 account. All right. Now, let's move on to step number 2, where we're going to start implementing the basic server-side logic for our Node.js server, right? Similar to day 1, again, we're going to initialize a new NPM project and install some of the required dependencies. For that, we'll be following the Learn Forge tutorial once again. Let me navigate to it straight away. So again, going to learnforge.autodesk.io this time. This is where you'll find the collection of tutorials that we've prepared for you. And today we're working on the tutorial number 2 here. Here it's called View BIM 360 and Fusion Models, right? That's the app we're going to be building today. And again, as during day 1, you can actually get access to a complete implementation of this app that we're building today for either Node.js, .NET Framework, or .NET Core. But what we're going to do is we're actually going to go step by step implementing the app from scratch. So we're going to start by step number 1, which is creating our server. And as usual, we're going to choose which language we want to use for that. And in our case, we're going to go with Node.js. And then we're going to, again, optionally for those of you using Visual Studio Code, we're going to create a launch configuration. That's basically a little bit of JSON telling Visual Studio Code how to run our application and debug it. And for example, what environment variables to set to it, to pass to our application. And then we're going to prepare the basic scaffolding or like a start.js file with the express server itself and config.js file where we're going to try and retrieve all the configuration properties from the environment variables. And we're going to implement a basic express router for the authentication endpoints. All right, let's get to that. So I'm going to start with a terminal. I don't have one here, so let me create a new terminal window. And again, if you're on Windows, you can either use command prompt or the git bash window that comes with the installation of the Git source code management utility. And if you're using command prompt, I believe installing Node.js to Windows will also give you a link to command prompt with all the Node.js commands or binaries available, right? So again, you should be able to type in node or npm from your terminal environment. So that's what I'm going to do here. I'm going to switch to my online training folder, day 2. I'm going to create a new folder for our project. So for me, let's say I'm going to call it View Hub Models. I'm using the word hub here because, as we mentioned earlier, right, there are different Autodesk products built on top of Forge, such as Fusion Team or BIM 360, and they all keep their users' data in their own silos, right? And we call them hubs. That's like the top level of this hierarchy of structuring your data. Under a hub can be a BIM 360 or Autodesk Construction Cloud or Fusion Team, right? And the hub may include multiple projects, and each project may include multiple folders, and folders can have folders or documents as subfolders or items in them, and items then consist of versions, right? That's the complete hierarchy, where again, hub is at the top level. So here I've just decided to call my project View Hub Models because this time we're viewing our designs in, again, Autodesk Construction Cloud, Fusion Team, and BIM 360. All right, we're going to start by initializing our Node.js project. Again, I could either type npm init. That would take me through a couple of questions asking about the name of the project, the author, the license. But for now, I can just append -y to basically have the initialization go through automatically initializing all the settings to their defaults, right? So I'm going to do that. It's going to create a new package JSON for me. That's the manifest that represents our Node.js project with the default. So the name of the project is set to the name of the containing folder. And author license is set to ISC. You can change it to whatever you want, and author and others are empty for now. That's perfectly fine. Now, the important piece is we need to start installing dependencies, right? So just like during day 1, we're going to be using a Node.js module called Express or express.js. That is a web framework, right? So instead of us having to go very low level and start building code for handling all the details of HTTP requests and responses, we can use Express, which provides like a nice abstraction layer that allows us to build server-side endpoints very easily. We're going to use another module called cookie session that is used to store some custom information in the user's browser, right? So that next time when the user visits our page, for example, they don't have to log in again. We can try and retrieve some information from their cookies and see, oh, they're still, they maybe logged in 2 days ago and their access token is still valid. So we're going to use that. That's what we're going to do that's what we're going to use the cookie session for. So there are different ways of storing, session data. In this case, we're just going to store some information like the access token and its expiration date in the user's browser in form of cookies. And finally, we're going to use Forge API's NPM module. That is the official SDK for actually communicating with Forge. So again, Forge services are web services or REST APIs, which means that you can communicate with them using standard HTTP requests, right? From any environment that can make HTTP requests. So you could be using things like tools like curl. Curl is a command line utility for making requests to HTTP requests, right? Or there are like GUI clients for HTTP requests like Postman or Insomnia, or you could communicate with Forge. You could be making these HTTP requests from your custom code. And again, you could either go low level and build the HTTP requests from scratch, defining the URL, the method, the payload, the request headers and everything, right? You could still do that. That would work just fine. But for some of the most frequently used languages like .NET or Node.js or Java, we provide official SDKs for those specific languages that expose the Forge functionality as classes and methods, right? So that you don't have to go all the way down building HTTP requests from scratch. You can instead just, create a new instance of, I don't know, objects API class and call a method called upload file or upload object. And that will, under the hood, prepare the request and send it for you. So that's what we're going to be using it for here, right? The Forge APIs, the official Forge APK. And let me type that in here. So I'm going to install all three dependencies. So Express, cookie session, and Forge APIs. I can install them all together instead of these three separate commands. And I'm going to use the --safe switch to have NPM basically include all these dependencies, including their versions, into the package JSON file. So let me do that now. Let's install our three dependencies. And after that, we can check the package JSON file one more time. Package JSON, and you'll see that now it actually includes these three dependencies, including their versions, right? These are the versions that we currently install, so that later on, if we share this code with somebody else, then they want to get it running locally, right? All they need to do is just type in npm install inside that folder without any other arguments. And this will basically just take a look into the package JSON at the dependencies and their versions, and it'll install them automatically. If I run the command here, it won't do anything because the dependencies had already been installed by my previous command, right, into this node_modules folder. All right, now we can move on to actually working on our code from Visual Studio Code. So I'm gonna go to my VS Code instance, and I'm gonna open that folder that I had just created. That's on desktop, Forge Online Training, Day 2, View Hub Models. And again, one important notice here, in VS Code, there's no concept of solutions or projects, as in the standard Visual Studio when working, let's say, on .NET projects. In VS Code, it's very simple. Your project is basically a folder, right? A folder that you open in VS Code is your workspace. So the only thing you want to make sure is that you open the right folder, because sometimes some of our customers accidentally open the parent folder, right? Or maybe a nested folder. So what you want to do is open the folder that contains the package JSON file, right? As I did here. So you can see I have my View Hub models. That's the name of the actual folder. And that's my workspace. And the files I see here are at the top level are the package JSON, package lock.json. That's something that's been generated automatically by NPM. And the node modules. That's the folder where all our dependencies and their sub-dependencies are installed. So make sure, because then if you, for any reason, maybe accidentally open the parent containing folder, right? It would look differently. And then of course, VS Code could get confused if you ask it to run some specific file like start.js. It will not find it because that file at that point would be in a different subfolder. All right, files and folders. Let's go back to VS Code. Just like during day one, we're going to be building, again, a simple Express server application with a couple of routers and some public client-side assets. And it's a good practice to store those in separate folders. So I'm going to create a top-level folder called routes. That's where we're going to store our Express routers. That's where we're going to implement the logic for the different server endpoints, right? And we're also going to create a folder called public. This is where we're going to store everything that's supposed to be sent to the client, all the static assets like the HTML, the CSS, and the client-side JavaScript. All right. Now, those of you using Visual Studio Code, again, it's a good idea to create a launch configuration for VS Code, which again is just a little bit of JavaScript specifying when you run and debug your app, which Node.js script should be triggered and what environment variables should be passed to it. And you can do that by heading over to this run and debug section in the sidebar in VS Code. And you'll see for now, it doesn't really allow you to debug anything because we haven't created any configurations yet. But there's a link called create a launch JSON file that will create a default configuration for you. Let's click on that link. Now, again, here for me, I see a couple of errors because I've got some other languages installed in VS Code and they're trying to offer their options to me as well, but I don't want those. Because here from the list of all the available environments that I may want to create the configuration for, I'm just going to choose Node.js, right? That's what we're working with today. When I do that, VS Code will create a new folder with a launch JSON file in it, right? So it says, okay, you want me to run a certain file, right? And you want me to call this configuration, let's say launch program, or I can call it launch server. Now for the remaining settings, well, let me actually just copy the entire piece of JSON from the list of configurations. You can have more of those, right? For now, we just need one. So I'm just going to copy the inside of the configurations array and replace this one with it. So at this point, at the top level, right, the JSON says there is a list of configurations. There is just one. We call it, again, let's say in my case, I've decided to call it launch server. And what it's going to do is it's going to run a start.js file in the root of our workspace. There's going to be a file here soon called start.js with the logic for our server. And it's going to pass a couple of environment variables to the process, right? To the Node.js process. So this is where we're going to use the forge client ID and client secret and callback URL that we've specified in our application. Now let me go back to the Forge portal, look at my applications, find the app that I've created today. All right, copy and paste the client ID and client secret. Also, be careful about accidentally pasting some weird white spaces or weird symbols before or after the string, right? Otherwise, you may start getting weird 401 authorization errors. And for the callback URL, what I'm thinking, okay, so I may have made a mistake when I was typing the callback URL here from the top of my mind. I used API Forge OAuth callback. It looks like it might actually be the other way around, but let's keep that for later once we actually get to the point where we start implementing the server-side endpoint for this callback. All right, so for now, this should be enough for our launch configuration. And again, for those of you who don't want to use Visual Studio Code, that's perfectly fine. You can run your Node.js server just from command line or from WebStorm or any other editor, really. Just make sure that you pass these three environment variables to that Node.js process, right? So from command line here, in case of Bash, I would do that by saying, forge export forge client ID equals something, right? And forge client secret equals something. And then in command prompt on Windows, you would do that by typing in set forge client ID equals something. Right, so if you want to run your app from command line instead of from VS Code, just make sure that these 3 environment variables are defined, because these are the configuration inputs to our Node.js server. All right, now we move on to our start.js. This is the entry point JavaScript file that will define the logic for our Express server, right? I'm going to copy the content of this snippet to clipboard. And here in the root of our workspace, I'm going to create a file called start.js. And again, notice that that's the file that we're going to be launching with our debugger in VS Code. All right, this is our start.js file. So let's just take a quick look at what we're doing here. Again, we're bringing in a couple of built-in Node.js modules like path. This is using typically to resolve file system paths. Express, that's the Express.js module that we're going to use to actually create our Express server. And cookie session is the module that we've also installed as a dependency that we're going to use to insert as something called middleware, which is also a topic that we discussed during day 1, but we can quickly repeat it here. That's going to handle storing and retrieving some custom information for our app in the user's browser. Right? All right. Then what we're doing here, we also import another JavaScript file here that's going to be that we're going to create pretty soon. This is the same thing. We can just type in /config, which means this is a relative path, right? So in the same folder as this script itself, we're going to be looking for a file called config.js and import it. And then we're going to check if the imported object includes the properties that we expect. And if not, we error out and return immediately without starting the server. Then we create an Express server application and we add a couple of these middlewares. So again, very quickly, Express uses this concept of middlewares, which are basically small pieces of code that you can stack on top of each other. You can build this stack of middlewares, and any incoming web request handled by your server will flow through these pieces of code, and every piece of code will have a chance to answer to this request, right? Or pass it forward further down. And then basically, and any of those middlewares, right, that if it decides to, okay, I want to handle this request, it can trigger a response, and that response will bubble up back through the stack and will be sent back to the client. That's the concept of middlewares, right? So each middleware, again, can be as simple as like a one-line function that does something that either takes a look at the request and sees if it makes sense for it to react to it, or just lets it, go further down the stack. And a couple of these middlewares we're using here are this one, express.static. This is basically a middleware for serving static files. What this line will do is basically any request that will come into our server, this line will check if that request, let's say localhost colon 3000/index.html, it will try and see if this index.html is maybe a local file somewhere in our code. In this case, it will be looking into the public folder, see? So it'll try and take a look inside public folder if there is a file called index.html. And if there is one, this middleware will send it back to the client, ignoring the rest of the stack, right? Similarly here, what this middleware will do is it will take a look at the cookies in any incoming web request, and if there are any, it will read them. It will actually decipher them, because you'll see here we're going to be using some kind of a secret to cipher and decipher the cookies that we store in the user's browser, right? Because we don't want them to actually see the actual data that we save in their browser. We want to, encrypt it so that it cannot be, stolen. And when this middleware finds any of these cookies, it will read them, decrypt them, and make them available on the request object that will then bubble through the rest of the stack, right? So in all our additional endpoints that we're going to be implementing, we don't have to worry about cookies and decryption anymore, because all the cookie information will already be decrypted and available there. And finally, on line 19 here, we're adding a JSON parser. So that's a middleware that basically takes care of looking at the content type header of the incoming request. And if it's a JSON, it will take the body of the request and actually parse it into a JavaScript object. And here we're also specifying that we will refuse to parse any JSON that is larger than 15 megabytes, right? Because somebody could try like a DDoS attack on our server by sending in a crazy large string and basically trying to trick our server to try and parse it as a JSON. And then later on, we will be adding our custom express routers that will handle the different server endpoints. For now, let me comment these out because, of course, we haven't defined any of these files yet, right, in the routes subfolder. So personally, I prefer to just keep the .js extension to make it clear that we're looking for a local JavaScript file. And finally, this is going to be something at the very bottom of the stack. There's going to be like a catch-all mechanism, right? So if none of the other middlewares were able to answer to that incoming request, it'll reach this final middleware that will just say, error, and it will respond with the error as a JSON with some error status code. Let's say 400 or 404 not found. This is also a good practice to keep this, again, catch-all at the end of the stack if, none of the other middlewares that were supposed to respond to this request were able to. And finally, we run our app on a specific port. By default, we use 3000, and that's it. That's all for our server. Right. And finally, the config.js. We also like to separate the preparation of the config properties and config options in a separate file before we run our application. So we typically, in our samples, especially here on LearnForge, we put them in a file called config.js, also at the top level of our workspace. And what we do here is we basically just cherry pick stuff from the environment using process.env. This is where we're looking for the environment variables that should be passed to our application, right? Either by VS Code or by, again, WebStorm or by the terminal environment. So we try and retrieve these and store them in this arbitrary JavaScript object that has credentials and scopes as the two top properties, right? And the credentials object then includes client ID, client secret, and callback URL. And here we also include some additional configuration options that we don't really need to retrieve from the environment, but we still want to keep them in one centralized place, right? So anything that has to do with configuring our application, we place it in this config.js file so that it can be easily reused in different parts of our code. In this case, we're using this scopes property to define the Forge access token scopes, which means basically the privileges that we're going to give a certain access token. We're going to use two different types of access tokens. One that we're going to generate for the viewer, so a token that will be shared with the client side. That token will only have a single privilege, and that is viewables column read, which means it will be able to read models, 2D drawings and 3D models from Forge. But then for our internal operations on the server side, we're going to have another token that will be more powerful. That token will be able to create buckets, read files, upload files, or modify existing files. So that one we call it internal. And so we're going to use that type of token, generated token, only on our server side. We will not share it with the client because it's not a good security practice, right? Because if for any reason somebody got hold of the access token from the browser, let's say, right, they could use that token for the limited amount of time during which it's valid before it expires to actually manipulate content, right? So it's a good practice to limit the privileges of the token that you share with the client as much as possible. That's why we're going to use two different types of tokens with two different sets of privileges. All right, that's our config.js. So you'll see here, we're basically trying to import it into our start.js file. And again, if client ID or client secret are not defined, we will just print out an error and end immediately. And for going back to this cookie session for a little bit more, the keys are, again, this is something that in a production application, you probably don't want to hard code here. This could be my super secret password, right? But of course, it would be good to later on. This is just for demo purposes, but this would be a password that would be used to encrypt and decrypt all the cookies, right? So of course, again, it's not a good idea to keep that string in your code. So this could also be an environment variable that you would retrieve from the running process. So I'm just going to leave it here for now. And that's it for the Express app scaffolding. And I think we can move on to the next part, which is implementing the authentication endpoints. Now, this is where things are starting to get a little bit different from what we worked on during day one. During day one, we only added one endpoint that was used to generate the public access token, right, with the only privilege, which is reading models from Forge. And that endpoint would return the access token to the client as a JSON. But in this case, we're going to need to implement a couple more endpoints. And before we get to that, let's take a quick look at the where are we going to go? Here, at the documentation for the authentication service, to better understand what the difference is and why we need to have this, a bit more complex process for this login system. Let me see if I can find the three-legged. It was a nice diagram here. Yeah. So what this means is when we are working with something called three-legged authentication, means that we need to establish trust between three parties, between Forge, between your application, and between the user, right? Up until now, we've been using two-legged, so the trust was established between your app and Forge, but now there's this third leg, which is the user. So you need to actually ask the user for their approval as well, and only then you will receive an access token, a so-called three-legged access token that you'll be able to use for any kind of Forge requests that actually require three-legged tokens. And the workflow is like so. You'll basically redirect your user to the Autodesk login UI, right? There, the user will be able to enter their Autodesk credentials, and if they're valid and confirmed, they will be redirected back to our application with a specific code in the URL, and from there, we will need to pick that code and make another request to Forge to exchange that code for an actual access token. Here, yeah. So once the user is redirected back to us, we will retrieve that temporary code that is valid only for a very short amount of time, and we will immediately need to send that code to Forge to prove that, okay, the user was redirected back to our application. Here's the temporary code, and Forge, the authentication service, will return the actual access token, and we can then store it in the user's browser using cookies and use that token for any additional Forge communication, like, for example, asking Forge for the list of hubs that the user sees, or asking Forge for the list of folders that the user sees in a specific BIM 360 project. All right. So now let's move on to implementing our server-side endpoints. Again, we will create a file under our routes folder called auth.js, where we're going to define a couple of server-side endpoints. auth.js. So I've copied and pasted the logic from the LearnForge website. And again, let's take a quick look at what we're doing here. We're going to bring in a helper class from another JavaScript file, which is going to be available in a subfolder here called common. under routes. We're going to implement it very soon. And we're defining a new express router. Again, that is a piece of code that defines how different endpoints can be handled on a specific subset of URLs, right? So this OAuth.js will be, this express router will be attached to this string /API/forge. So any requests coming to our server, starting with /API/forge, will be passed to this express router. And this express router will try and see if any of these it can handle, right? So it will check if maybe if the request is /API/forge /callback/OAuth, it will try and process the request with this logic. If the request will be /API/forge /OAuth/URL, it will try and do this, right? This piece of code. So now let's take a look. We have 4 requests, 4 endpoints that we're handling here, right? First, a GET request to the, again, that would be GET request to /API/forge callback OAuth. I like to expand the full URL that this code would theoretically handle in the future, right? So if somebody makes a GET request to our server to this URL, API/forge callback OAuth, what we're going to do is we're going to try and retrieve some property from the query parameters called code, and we're going to use it to, as I mentioned earlier, to exchange this temporary code for an actual access token from the Forge authentication service. And we're going to do that through a method on this helper class OAuth that we're going to implement soon. And then we just redirect the user back to the front page, right? To just slash. Similarly, if we get a request, a GET request to API/forge OAuth URL, what we're going to do is we're going to build another URL. That's actually when we're redirecting the user to the Autodesk servers, right? So that URL looks like this. The shape of the URL is explained in the documentation on the Forge portal, right? So it's going to be developer API autodesk.com /authentication v1 authorized . We're going to include the client ID of our application. We need to include the callback where the user should be redirected to when they log in. And be careful here, this has to match exactly the URL that we've configured in our Forge app on the Forge portal. And finally, a list of scopes separated by spaces, but they're going to be, for URL, it's going to be replaced by, I believe, $20, the URL encoded variant. The list of scopes that we're asking for from the user, right? This is actually going to drive the UI that the user will see when they hit the login button, because they're going to see a form saying, oh, this Forge application is trying to ask for your permission with reading files, manipulating files, creating buckets, stuff like that, right? Based on the scopes we add here, the list of things the user will see will be longer, obviously. And then we just call response.end, meaning redirecting the user to this URL. And this one, if there is a GET request to API/forge OAuth sign out, all we're going to do is just set a session property on our request to null. And what that means is that, again, remember, we have a middleware sitting in our stack that will look for cookies in any incoming web request. And if it finds any, it will parse and decrypt the cookies and store them in a session property on the request object and pass it further down the stack so that any other request can, any other middleware can use that information. And what we do here, if somebody calls this sign out endpoint, what we're going to do is we're just going to set the session to null. We're basically going to invalidate any session information that the cookie session middleware might have decrypted. And then we're just going to redirect the user back to the index page. And after sending the response back to the client, the cookie session will notice that we intentionally deleted the session property. And what it'll do, it'll just basically remove any cookies that are sent back to the client. All right, and finally, the fourth endpoint, that's the get API forge OAuth token. That's the same one we used during day one. That's the endpoint we're going to use on the client side to obtain the public token for our viewer, right? The token that our viewer can later use to actually load content from Forge viewer. Oh, sorry, from the Forge model derivative service. And that's it for our authentication endpoints. Now, of course, we need to fill in the remaining helper OAuth class that we can find on the Learn Forge website. So again, that will be a file available under the routes folder, under a common folder. I'm going to create a new common subfolder here and a file with the same name. Again, apologies for the naming. I think it's a bit confusing to have two files with the same name. The reason we put this logic into a separate JavaScript file is because we're going to be reusing these methods like get public token or get internal token in other parts of our server-side code. Right, so we're basically just building a helper class called OAuth that will be able to do a couple of things. It will be able to generate a public token for us based on the public scopes that we have in our config file, right? And it'll be able to generate an internal token based on the internal scopes. And I believe we, again, use a caching mechanism here. Maybe not this time. Actually, we don't have to. So, and the rest of the implementation of the class is basically used to check, if the token is still valid, because whenever you generate a token, it's typically only valid for 1 hour. After that, you need to refresh it. Refreshing token is something that is described in the authentication service documentation page. So whenever you exchange that temporary code for an access token from Forge, you will retrieve a refresh token as well. And that is something that can be used to later on refresh the access token without having, without asking your users to log in again. That's all handled by this OAuth helper class and used by the OAuth, the authentication endpoints. All right, and that is it for session 2. So now it's your turn. Again, please take a look at, initialize your Node.js project and install the dependencies, the 3 dependencies listed on the Learn Forge website. So that's the Express, Cookie-Session, and Forge-APIs. That's the 3 modules we're using. If you're using VS Code, create your launch configuration. And again, don't forget to include the 3 environment variables that we're going to be using, right? The client ID and client secret of your Forge application and the URL. And again, this is the URL we will fix when we get to that point when we actually start. Well, actually, maybe you can do it now. So let's go back to our authentication endpoints, right? The callback that will be called looks like this, right? So it's going to be our server's domain /API/Forge/callback/OAuth. This is the address where the user will be redirected to after logging with their Autodesk credentials, right? So this is where we're going to retrieve the code property from the URL query, and we're going to use it to generate an actual access token for that. So with knowing that, we'll want to make sure of 2 things. First of all, that the Forge callback URL that we're passing in as an environment variable matches this callback exactly, right? So this is how it should look. API Forge callback OAuth. And now I'm going to take this entire URL, including the domain, localhost 3000 in our case. And I'm going to go back to our portal. This is day 1. So let me go back to the app that we're using today, which is day 2. And I'm going to hit the edit button here and update the callback URL, because here I used API Forge OAuth callback, but it's actually API Forge callback OAuth. Be very careful. Make sure that, again, this string that you configure for your application on the Forge portal matches exactly the Forge callback URL that you will be using in your code when communicating with Forge. If these 2 don't match, well, when your user hits the login button, they will get an error saying, oh, the redirect or callback URLs don't match. All right. And finally, again, set up your configuration object in config.js file at the root of the workspace, your default Express server in the start.js file, and then your authentication endpoints in the two files we used under the routes folder, the OAuth, and then on the common folder, OAuth.js. All right, that is it for now. Once again, I will mute and stop my video, but I'll be around. You now have around 1 hour and 15 minutes until we meet again to follow these steps. If you run into any problems, ask in the Q&A dialogue of Zoom, and we'll get to you and we'll try and help you out. All right, good luck. All right, everyone. Hello, welcome back to session 3 of our webinar today. In session 3, we'll be looking at some additional server-side logic for our Node.js Express server. This time, adding endpoints for listing hubs, projects, and documents, and also providing an endpoint that can share some additional information about the user who has just logged in, such as their name and profile picture, so that we can have something to show in the UI to indicate that the user is logged in. Once again, leaving a little bit of time to any last-minute questions about the previous step. I hope everyone has been able to set up their Node.js app and get their initial server working. For now, there is no way to try it out through a user interface. That's something that we're going to add. That's something we're going to add in the next session. Hopefully that is something we can survive without for now. All right, no questions. In that case, let's move on to step 3. Again, adding additional server-side logic for browsing our users' data and getting their information, their user information from Forge. All right, demo time. Let's go back to Learn Forge website. And again, today we're working on the View BIM 360 Fusion models tutorial. And now we're working on the third step, listing hubs and projects. This diagram indicates or explains something we had mentioned in the previous session, the structural hierarchy of content living in Forge, right? So at the very top level, we have a hub. And again, hub can be an application such as BIM 360 or Autodesk Construction Cloud or Fusion Team. It's a silo where all your users' content lives. And then each hub can consist of projects. So inside BIM 360 or inside Fusion Team, you can have multiple projects, of course. And then each project contains a proper folder structure of folders and documents and document versions, right? And this is something that we're going to be browsing through our user interface in our application. And all the way down, the diagram goes back to the OSS, that's the object storage service that we worked with during day 1. Right? So ultimately, all this hierarchy of hub, project, folder, item, version structure goes back to the standard buckets and objects that Forge also offers, specifically the data management service. Right, so I see there is a question. What's my VS Code color theme? That's an interesting question. I don't think I'm using any specific color themes. Let me check. I don't think I do. I think this is just standard VS Code default, I believe.
Well, I have black.
Oh, that's okay. So that's the dark or light theme. I think that's just settings. Theme is probably going to be in settings. Now, where do I switch to the light one? Oh, here, color theme, workbench color theme. So I'm using light plus. I thought that was the default in VS Code. Maybe it's the dark plus. Yeah, so I'm using light plus. Thank you, Deepali. All right, you're welcome, Ali. All right. And then, of course, also we'll need to be able to somehow differentiate between the different types of hubs that that the data management service will return to our request, right? So how do we know if it's a Fusion Team hub? How do we know if it's BIM 360 or, again, ACC, Autodesk Construction Cloud? And for that, we can use either a property that will be available on one of the attributes on the response we get from Forge, or as a quick check, we can also look at the prefix for the ID that we retrieve for that specific hub. So if that hub account is going to start with B dot, it's going to be a BIM 360 account. If it's going to start with A dot, it's an A360 account. Okay, let's move on to implementing our data management endpoints. So we're going to create, once again, an express router, and that router is going to handle a single endpoint, but that endpoint is actually going to be configurable through query parameters, once again, like the one we used for example, listing buckets in day one. So let me copy, and be careful here, this is not the entire implementation of that file, of that router. This is just the first half. So let me copy this code to clipboard, go back to our source code, and under the routes folder, create a new file called data management.js. Paste that snippet there. So again, this is going to be a router, once again, attached to the /API/Forge URL, right? So this router.get method basically sets up a handler for any get requests to API/Forge/data management. So any requests coming to this URL will be handled by this chunk of code. And here's what's going to happen. First of all, we're once again looking at the query parameters of our request. And just a reminder, query parameters are any parameters in the URL after the question mark, right? So if somebody makes a request to API Forge management ID equals foo, then these parameters will be parsed automatically for us by the Express framework. And then in our code, we can immediately check request.query.id. That way we'll try and parse any value, in this case foo, used in the URL of our request. What we do here is we also use this built-in JavaScript function called decode URI component. So JavaScript has a bunch of built-in functions like fetch and encode URI and decode URI components. Here what this is, when you have some piece of string that you want to use in the URL, that string could be unsafe, meaning that the string could contain things like forward slashes or question marks, which when included in the URL could mess up the entire URL, right? Because if there are some slashes in your string or question marks, the complete URL could change meaning, right? That's why it's important to encode and decode any strings that you're passing into the URL to make them URL safe. And this is one of the options. This is using URL encoding, where, for example, every forward slash and every question mark and every space is replaced with some dollar number, right? So for example, spaces are replaced by $20, I believe, because dollars are safe to include in the URL, and the percentage signs will not change the meaning of the entire URL. So what we do here, we're just taking some kind of value that was passed into our request as an ID parameter, right? So it could be foo bar. And this value will actually, after we run it through this method, the percentage sign, will end up as foo bar, or sorry, foo space bar. So we just decode the original string back that can contain these unsafe characters, because here that's fine, right? We don't worry about these special characters that could affect the URL here anymore, because this is no longer a URL. This is just some string that we're going to be working with in our code. All right, and then what we do is we check if that ID value is just a hash sign, and if it is, we just consider it that whoever made this request is just asking us for the top level information from our data, which is the list of hubs, right? So we're going to call a method, a function that it's going to be implemented further down in a second. That's going to list all the hubs for our user. Otherwise, if the ID parameter contains some other value, we're going to split it by forward slashes, and this is just our internal convention. You could split it by pipes or columns or any other separator you want. This is just, in our case, we expect that whoever's going to be sending this request to us, who's going to provide this ID query parameter, that it's going to be some types of strings separated by forward slashes. So we split them and we retrieve the last and second to last values from that string. We're going to consider them as some kind of like resource type and then resource ID, right? So based on the resource type, or here name, it could be either hubs, projects, folders, or items, right? So this is just our internal convention where the ID coming with the request in as a query parameter could be, for example, hubs XYZ, or it could be folders, right? Of course, again, we're not going to see the forward slash here. We're going to see something like, I don't know, something like this, right? So this is how the caller will let us know what kind of object he's trying to get the list from. So if they're asking us about hubs, about a specific hub, we're going to get them the list of all projects in that hub. If they're asking about content of a specific project, we're going to get them all the folders. And if they're going to ask for a specific item, if it's going to be items/XYZ, we're going to get all the versions of the document XYZ. And again, you have probably guessed by now, this one endpoint is going to be used by the JS tree jQuery plugin on the client side when we actually build the tree and we expand the individual nodes, right, to get the list of hubs, project, folders, items, and versions. Now let's go back to our LearnForge website, because again, you'll see here that we're calling many different helper functions that are not defined yet. We're going to add them right below this endpoint handler definition. So we move on further down on the LearnForge website. This is where the get hubs, get projects, and all the other methods are defined. So let's just go ahead and paste those at the end of our data management JS file. So that's what we're doing here. See, we have our helper function for getting the list of hubs, getting a list of projects, etc. And this is what they do internally. We're once again using the official Forge SDKs. So let me switch on to presentation mode here. We're using the official Forge SDKs, and here we're making a request to, in this case, to the Forge Data Management Service to get a list of hubs, right? So under the hood, this will once again do nothing else than just create an HTTP request, sets it request headers, accordingly, sets the request method, URL, and where needed a payload, and it will just make that request to Forge. It'll process the response and return it to us as a return value of this method call. So we're just going to get a list of all hubs, and this is the response we get, and we turn it into a JSON where it's going to be just an array of objects, with each object including basically a definition of a tree node with a link to the ID and name of that specific node in the tree. Again, whether it's a project, a folder, or item, right? And the type itself, so that we also know in the UI how to visually differentiate those elements, whether they're folders, items, or again, projects or hubs. And similarly for the other helper methods, right? When we're trying to retrieve the list of projects for a specific hub, we get a new instance of projects API class from the Forge SDK, and we call it get hub projects. When getting folders for a specific hub and project, we're creating, again, a new instance of project API class, and we're calling get project top folders. And all these, again, you will find the exact equivalent for all these methods in the API documentation of the Forge data management service as the different HTTP endpoints that you can call. All right, that is our data management endpoint. So again, just make sure if you commented it out in the start.js file like I did, make sure to uncomment it. And the data management piece is now ready. The second part of this step is, like we mentioned earlier, adding an endpoint, a server-side endpoint that will provide some additional information about the logged in user. In this case, we're going to create another express router in a file called user.js in the routes folder. So let's go back to our routes folder and create a file called user.js and copy the code snippet from LearnForge website. What we're doing here, again, just implementing a single get request handler for any request coming to /API/Forge/user/profile, right? Because once again, this express router is mounted to this prefix API Forge. So any requests, so any kind of string that you use here, this is just a partial URL that will be connected with the rest of the URL that this router is connected to. So any get request to this URL will be handled by our code here. And what we do is we simply retrieve an internal token from our helper authentication class that we implemented in the previous session. And we once again use the official Forge SDKs, create a new instance of user profile API class, and call the get user profile method. This will retrieve, because now the token we're using here, as we mentioned earlier, is three-legged, right? So this token now represents some, again, trust that was established not only between your app and Forge, but between your app, Forge, and a specific user. So thanks to that, you can use this in simply calling get user profile without any custom parameters, just by specifying the three-legged token. This method will return information about that specific user who went through this login workflow to generate this specific three-legged token. And from the response, we then cherry pick the first name, the last name, and one of the sizes of the profile images, and return the URL to the image as a JSON response back to the client. All right. And that is it for this part. Now we can, I believe we should be able to try this out even when we're, even if you don't have a UI yet, right? And the reason we can try that is because all these endpoints can be, called from any environment. They don't have to be called just by your specific website. You can just type them in, again, into a curl command line or into a browser URL address bar, or using any of the third-party HTTP clients like Postman or Insomnia. So let's try something. We know that eventually when we start working on our UI, there's going to be a button. There's going to be a button that will redirect us to the Autodesk login forms. Right? The URL will look like this, and we can retrieve the URL by making this GET request. So let's try something. Let's run our app. All right, our app is running and listening on port 3000. Let's go to localhost 3000 /API forge OAuth URL. Oh, localhost, loca. Do we have any Spanish-speaking people here? Loca? All right, let's try localhost. There we go. This is our URL that eventually, when we have our UI ready, will redirect us to this URL to trigger the login workflow, right? You'll see this is, again, the forge specific URL where we say this is the client ID of our app. Later on, when the login is successful, this is where we want to be redirected to. And these are the buckets that we want to ask the permission for, right? So let's try something. Let's take this URL and notice that this is actually not safe. The URL isn't safe because we're passing in a parameter that includes, again, slashes and colons and spaces, right? So that's why, again, that URL encoding is needed. So we can try something if Chrome can actually fix that for us. What happens if I go to Chrome and I paste this URL that contains these unsafe characters? Is it going to work? It will. See, okay, so Chrome luckily fixed the unsafe address for us. So it replaced all the spaces and slashes with the percentage number values. And now, so we're now at the, notice we left our application. We're no longer at localhost. We're now looking at autodesk.com. And we're being asked for our permission, right? So our app is asking for permission for the following types of operations: data, write, manage, view, and storage, right? We see these two main objects in the list because of the data scope that we use. Sorry, the scopes for the access token. I'm going to say, yes, I'm allowing this application to access my data. And now Autodesk will redirect us back to the callback URL that we've configured for our app, right? In our case, that's going to be localhost 3000 API forge callback OAuth. So you'll notice that if I hit the allow button, I'm going to be redirected back. Oh, yes. So this worked. This worked, right? So we were redirected to localhost 3000 /API/forge callback OAuth. So our server was able to retrieve the temporary code and turn it into an access token. But now, if you remember, we take a look at the authentication endpoint here. From after we successfully exchange the code for the token, we redirect the user back to the index page where, again, we still don't have any UI, right? That's why I got this cannot get flash, because there was no middleware in the stack that was able to answer my request for the index page. But let's try one more thing. If I open the DevTools from my local host and I go to application and the cookies, see, there's two new cookies that were stored to my browser by this server app. They're called forge session.sig, and they're encrypted, right? This is because when we set up our server app, we said, okay, store everything under a cookie called forge session, but encrypt everything with this secret password. That's why we only see this, weird string here. This contains all the data that we wanted to, that our server-side application decided to store in our cookies. We store it in form of a JSON, but it's encrypted so that even if somebody was able to, smash me in the head and take over my laptop, they wouldn't be able to steal the access token from here. All right. So that's for the authentication piece, right? So now our app is authenticated, and now whenever I make a request to localhost 3000, these cookies will actually be sent along with the request. So our server side, the cookie session middleware will decrypt the session values and make them available for the rest of my code, right? So I'm considered as logged in to our Forge application. So we can try something. Let me go back to our data management endpoint. And what was it? So it was API/forward/data management, right? So if I go to localhost API/data management, and I'm going to say ID equals hash sign, right? That means basically we're asking for the top level list of all hubs. Maybe that didn't, 500. All right, so our request failed with 500. So let's put a breakpoint in here and see why. All right, so, I see why. All right, so what's happening here is I manually entered ID equals hash sign, but once again, this is the unfortunate behavior of URLs, right? Because in a URL, hash sign has a specific meaning. That's a URL fragment. So when you have some anchor on your page, you can use hash followed by the name of the anchor to actually have the browser open the page and move actually to that section that you want. So this is confusing the URL in our case, right? So by the time it gets to our code, the ID value is no longer a hash sign, it's empty. And because it's empty, we decide to just complain with 500 and return immediately, right? Let me just maybe quickly change our code here and say, if href is empty, just set it to a hash sign, right? So this is going to be our fallback system. So if no ID query parameter is provided, we're just going to assume that the user, whoever is making that request, is asking for a list of hubs. So let me run my app again. And let me call this request, make this request one more time. So let's see, our href is empty. So we replace it with the default. Yeah. Oh, it's const. We cannot change it because it's const. Ah, forget, sorry. Let's try it one more time. So now it'll work. So we default to hash and everything else proceeds as needed. And there we go. See, so now we made a request to API/data management, just nothing. And we see that I have access to just a single hub, and that is a hub with this ID. It starts with A, right? So that's most likely going to be my A360 hub. And now what I can try is I can take this URL and add it here as hubs slash, let's see if that works. So, all right. The ID parameter now that we've received in a URL, luckily now it went through. So it's hubs slash something, right? Some ID. So here we're gonna be able to detect that the type of the request is, we're looking for contents of a hub, and the ID is this a dot something. So we should hit the hubs switch case, and I'm calling the get projects. Here, we're just going to use the Fortress D case, call get hub projects. Now in the response, there's a status code, headers of the response, the body, which is going to contain a property called data, which includes all the projects that I have access to in that specific hub. So we're going to return them as JSON, right? So these are the endpoints that we're going to use in the next and final session to actually build the tree structure in the sidebar. So it all works. Right. Now it's going to be your turn one more time to follow these steps and add the data management endpoint and the user profile endpoint. That's actually something we haven't tried. We'll probably give it a try one more time, unless there are any questions, to see that we're also able to retrieve my own profile information with my three-legged token. So I saw there was a question, but Deepali or Cyril have probably been able to answer that already. So thank you so much for that. And there's a comment in the chat. Nope, oh, that was just the VS Code color thing. All right. So let's take a quick look. Again, think about any questions you might have. In the meantime, we'll also do a quick test of the user profile endpoints. These guys, right? So when somebody makes a GET request to API for user profile, we should get a JSON with my name and a URL to my picture. So let's try that. Let's run our app one more time and go to localhost 3000 API for user profile. Boom, there we go. Here's our JSON with my full name and a URL to one of my profile pictures. Look at that, handsome. All right. That is it. Our server-side endpoints are working as expected. So again, try and follow these steps. You can find the code snippets on the LearnForge website. So just add the data management endpoint and the user profile endpoint that returns this JSON that we just saw. And again, one more time, if you have any questions, if you run into any problems, drop us a note either in the chat or in the Q&A panel, and we'll get to you as soon as possible. Otherwise, we're, again, exactly at the mark, 30 minutes. So now you have an hour and a half to follow these steps. And then we're back here for the final session where we're going to add the user interface and wrap up our application. All right, good luck. All right, we're back for the fourth and final session of our webinar today, where we're gonna implement the front-end piece, add a little bit of HTML, CSS, and some client-side JavaScript that will tie everything together and it'll make use of all the server-side logic that we've implemented so far. And that will be our application today. All right. Now, a little bit of time for any questions. Last minute questions. There was one during this gap asking about a way to check the credentials, the access token, sorry, that it's being passed between the server and the client. So while we're waiting, maybe there are for some other questions, let's take one more look at that. So if we run our application again and go to the index page, localhost 3000, we'll probably get error cannot get / because again, we don't have any middleware that was able to answer the request for this specific index page. But if you open the DevTools in Chrome or in other modern browsers as well, navigate to application and cookies. Now, this might be a bit different for other for other browsers, but you should still be able to find cookies somewhere in the DevTools of the browser of your choice. You should be presented with a list of domains and the cookies stored in your browser for these specific domains, right? Because the cookies are typically stored for some website. In this case, since we're working on our local host, we have the Forge session cookies stored by our server for this localhost 3000 domain. And again, the name of this cookie, Forge_session, is just simply something we've configured for our Express app, right? And the reason we see this weird string for the actual content of the cookie is because the cookie is encrypted. Now, there is one more quick trick you can try to check the behavior of this cookie session middleware. Let's try something. We're going to add one more middleware, which is again just a function, typically in Express, that just accepts a request, response, and a function that should be called when we're ready to pass the control to the next middleware in the stack, right? And what we're going to do is I'm just going to log the request object to the console. And we're going to do the same thing before and after this, the cookie session middleware on the stack, right? And maybe to be able to view the, to stop the execution right inside the, I forgot what we should call the next function, to pass it further, right? So pass the control to the next middleware in the stack. We're just gonna put breakpoints here so that we can actually stop it during the execution and see what's happening there. All right, so now if I go back to my app and I try and reload it, you'll see that we've first hit this bogus middleware before the cookie session was in place. So now if we take a look at the requests, it may include some, I'm not sure if we'll be able to read the headers, for example. Maybe not. But there's definitely no session object on the request, right? There is no session property on this request object. So because the Express framework hasn't gone through this middleware yet. It's going to get there soon. So now when we let it play, now we actually see that, okay, we've intercepted the incoming web request at another layer in the stack. And this time, when we look at the request object, we can see that now there is a session object, right? Session property. If I type it here, rec.session, this is our session. And you can see it's just a JavaScript object, which is now decrypted, right? So it's not the weird string we saw in the browser, in the DevTools. It's been now, it's been reconstructed and decrypted so that we now actually see the properties our server is storing in the cookies. So we're storing the internal token, public token, and refresh token, right? So all these three values, and then the expiration, actually. So these four values are what our server-side logic is storing in the cookies, and then later on reading to check if that token is still valid and can be reused for other requests, let's say 2 days later when the user comes back, or whether it's expired and we need to refresh it using this refresh token. So this is one way for you to check even what's happening on the server side, right? Where when we hit this line, this middleware in the stack, there was no session data available yet because the request hasn't been processed by this middleware yet. But then later on, the request, when we check the request object, the session data was already there and decrypted for us automatically. All right, so let me remove this. And I see there are no other questions, so I think we're good to proceed to our final set of steps, and that is the front end. All right, let's head back to our Learn Forge website. And we move to the final step in the View BIM 360 and Fusion Models tutorial. And again, this is pretty independent of the server-side programming language. So this should be the same no matter whether you're building your app using .NET, .NET Core, Java, or Node.js. Now we're just going to be adding client-side assets, HTML, CSS, and client-side JavaScript. And again, just like during day one, we will be placing all these static assets under the public folder, into CSS subfolder and JavaScript subfolder. So let's create these folders first. So again, it should be under the public folder. Remember, this is where this Express static middleware will be looking for any files that we may be asking for. Right, so let's start by an index.html file. This is where we're going to have our main page markup, and let's create two subfolders under the public folder, CSS and JS. This is, again, a good practice to keep your static assets separated. All right, so let's start by the index.html. We copy the markup to clipboard and paste it into the index.html file. The index.html file should be all lowercase. On the LearnForce website, it appears with uppercase I, but that is because it's a section title. So don't get confused by that. And let's take a quick look at what we have here in the markup. We start by the head element that contains that is bringing in some dependencies, right? Some external JavaScript files or CSS style sheets. We include a couple of scripts and style sheets for Bootstrap. That is the CSS framework created by Twitter that we're using to make responsive layouts, CSS layouts easily. And we're bringing in also Autodesk Forge Viewer dependencies. So Forge Viewer is the only outlier in the Autodesk Forge portfolio. It's not a web service, it's a JavaScript library for the client side, for the browser, right? Built on top of the WebGL standard. So we're bringing in a script file called viewer3d.min.js. It could be also viewer3d.js that includes all the logic for the viewer so that we can instantiate it, place it in the page, and control it. We also bring in a style sheet for the viewer, which includes some basic styling for the toolbar and all the UI, right? The panels, things like that. And finally, we're also bringing in our own assets, our own CSS and client-side JavaScript files. You can see that these don't start with HTTP or HTTPS or // These are just local relative paths to where this file is located, right? And since this file is in the root of our domain, it's on localhost 3000, all these relative paths will be resolved to localhost colon 3000 /CSS /main CSS, for example. And what we're going to do is we're going to place these files under these CSS and JavaScript folders in the public folder. And that's, again, because the static middleware for static file sharing, when it receives a request to localhost 3000 / let's say JS / forge3js, it will peek into the public folder and see if there is by any chance a file in the JS subfolder called forge3js. If there is, it will respond to that request immediately, sending that content of the file back to our browser. All right, and then in the body, there's just a standard Bootstrap boilerplate, right? So we have the navigation at the top. We will have some just a logo and a title for our app. Then we have the actual container where we're going to have the user hubs. That's going to be the sidebar, right, with the hubs, projects, and everything listed in the tree. That's going to be the JS tree plugin for jQuery. Finally, there's going to be the rest of the real estate on the right is going to be used for Forge Viewer. Oh, and we also use this hidden iframe here. I'm going to explain its use later when we get to it. So that's for our main markup file. Now let's add a little bit of styling to a file in the CSS subfolder. We're going to call that file main.css. And again, it's going to be lowercase, main.css. And here we're just defining a basic styling. We're basically saying that the body HTML element is going to occupy the entire height of the page, right, of the browser window. The .fill, that's a class that we're using in a couple of places in the HTML markup. That's basically saying we want to use the entirety of the height, that the VH stands for viewport height, and it's basically percentages of the viewport height. So we're using 100% of the viewer height or viewport height, and we're subtracting 100 pixels. We're leaving basically 100 pixels at the top for the navigation toolbar. And since this is a class, you will see that we're using it in different places for the different top level containers, right? So make sure that all these divs leave the 100 pixels at the top for the toolbar. And yeah, and there's going to be a little bit more padding at the top for the body element itself and some margin. And this is the the user hubs is going to be the div where the tree is going to live, right? So we're just going to set overflow to auto, making sure that if it's too large, that it doesn't actually force the HTML markup to stretch beyond the limits of the viewport, but by setting overflow to auto, we're basically saying if it grows too large, just show a scroll bar and make the user scroll that area. And yeah, and for the viewer itself, we're just making sure that the div will occupy the entire width of the real estate that's available to it. That's for our main CSS file. And we can move on to Forge tree. Now, this is an exception here for these two JavaScript files. These are with uppercase F, in this case, uppercase T. So we're going to go to the JS subfolder of our public folder and create a new file called Forge tree.js. This is the client-side JavaScript that will control the behavior of the tree on the left side in the UI. Again, quick review of what it's doing. This construct at the very top is $document ready. That's basically a way of jQuery. jQuery is this relatively old but still used library for easily manipulating HTML and DOM content, right? And this $document.ready basically means take the document that's the top level object representing your entire web page and add an event listener to when it's ready, when the entire HTML page is ready. And when it is, call some callback function that we've provided here. So what we do is we say when the HTML page is ready, make a request to our server specifically to the API Forge OAuth token endpoint that we've implemented in our server. And if you remember, this is the endpoint where that we use to get the public token that's going to be used by Forge Viewer, right, to access our models in Forge or in BIM 360 or Fusion Team. And then when successful, we just set the user interface to in a certain way, right? Because if the call is successful, it means that, yes, we are already logged in. In that case, we find a button that is used to log out, and we show it. We find a button that is used to refresh our tree, and we show it because it's hidden by default, right? And we set some events. So when somebody clicks on the sign out button, what we're going to do is we're going to make a request to our server to this endpoint API Forge OAuth sign out. So again, if you remember, what this endpoint is doing is it's just taking the reg.session, right? The session property on our request object, and it's setting it to null. And with that, it's basically asking the cookie session middleware to reset any cookies for our page. And through that, the browser will then appear as if the user was logged out. And also, now is the reason. Now we come back to the hidden iframe that you saw in HTML. This is a small trick to actually to log out the user properly, because by simply cleaning the session, that means that yes, the user is now logged out from our Forge application itself, but the user still hasn't really logged out from Autodesk itself. So what that means is that if somebody else jumped in your seat and hit this login button again, they would not be prompted for their permission because they would be redirected to Autodesk, to the Autodesk login page. But that login page may still think that you're logged in, because that auth.autodesk.com page may still have its own cookies set that remember that you have logged in. So to actually force the complete logout of this user, not only from our application, but also from the Autodesk login website, we take this hidden iframe and we set its URL to https accounts autodesk.com authentication logged out. And by that, we basically make sure that you get logged out not only from this Forge app, but also from Autodesk. So next time somebody clicks the login button, they will basically be redirected to Autodesk, but then they'll be presented with, enter your username and password, and this application is asking for your permission, right? They'll be presented, they'll go through the same login workflow as the first time. And there's then a couple more settings in the UI. We also set a click event on the refresh hubs button, right? And what we do here, this is again the construct where when you use any kind of jQuery plugin, the plugin is typically activated by calling some special function on a jQuery wrapper object. So here we create, with this part of the statement, we create a jQuery wrapper object for some div element on our page that's called user hubs. And by calling .js3, we activate this JS3 jQuery plugin for this element, and then we can call some methods on the plugin, right? And one of the methods on the plugin is refresh, which basically means just refresh the entire tree structure. And a couple more things we actually populate the tree with hubs, projects, folders, items, and versions. And we also set up the UI for the user itself. Let's take a quick look on the show user. That one's going to be easy. What we do here is we make another request to our server, this time to the API Forge user profile endpoint, which, if you remember, is the endpoint that is supposed to return a JSON with the user's name and a URL to the profile picture, right? So we're going to use that to show the name and actually the image as well, somewhere, you know, in the user interface of our application. All right, and for prepare user hubs, let's take a look at that one. Again, what we're doing here is we're activating the JS3 plugin for a specific div element, in this case, the one called user hubs. And we're setting up the JS3 plugin through some additional options here. We're basically saying, okay, we want to show icons, right? And here we're specifying how the tree is supposed to get its data, right? You can either just paste in an JavaScript object that will be turned into the tree structure, or another option for the JS3 plugin is to give it a URL that the plugin should call whenever it needs to get some, you know, objects in the nodes in the tree at certain level, right? If you remember, that's what, when we were implementing the data management endpoint, here it's a single URL, right? That's the one we're going to be calling from the tree plugin. And the tree plugin will first call this URL with the ID query parameter set to hash. That's the top level, right? And then later on, when you, let's say, expand one of the hubs, it will call this again with this endpoint again with, let's say, the ID query parameter set to hubs slash something, some ID, right? So this is why we came up with this way of, like, you know, having a single endpoint that can return different things based on the ID parameter that you set to it. We did it this way because that will make it easy for our tree plugin to consume that URL easily. That's it. And then some styling for the tree as well, where we're specifying what icons should be used depending on what type of node that is in the tree, how it should be sorted. And then also you can add different event handlers for the tree structure as well. So for example, when a node is activated, meaning when a node in the tree is selected, we check if it's of type versions or BIM 360 documents. And if it is, we try and retrieve the URN of that node. That URN, again, is the base 64 encoded object ID of some design inside Forge that you can then pass to the viewer and have the viewer load the model for you. So that's exactly what we do here. Okay, so launch viewer, that's a function that's going to be defined in the other client-side JavaScript file called Forge viewer.js that we're going to add right now. So we've got our Forge tree behavior ready, and now for the Forge viewer.js. So let me again copy the content, this code snippet, and create another file under the JS subfolder called Forge Viewer with uppercase F and uppercase V. So here we just define a global variable called viewer. This is where we're going to store the reference to the instantiated viewer itself, right? That's an instance of viewer 3D or GUI viewer 3D class. And then we provide a get forge token function that's going to be used by the viewer whenever the viewer needs a new version of a token to communicate with the forge servers. Right, and again, it's simply going to call the API Forge OAuth token on our server side that will return the public token. The public token with the only scope, which is the viewables read. So the only thing this token will be able to do is just view models from Forge. The launch viewer function, the one that is being called from, when you click on a node in the tree, what it does is it calls the Autodesk.viewing.initializer, which is a global function that is used to make sure that all the additional dependencies, things that Forge Viewer itself may depend on, that may be like some additional JavaScript libraries or images for maybe environment maps and things like that. Those will be downloaded during this Autodesk viewing.initializer call. And when it's ready, you just pass in a callback explaining what you want to happen after the dependencies have all been downloaded. And what we do there is we just create a new instance of our GUI viewer 3D. That's the actual instance of our viewer. And the first parameter to that constructor is the HTML element where you want the viewer to live, right? So we already prepared a div element in the HTML markup called Forge Viewer. So we're saying, we want you to occupy this div element. And then there are some additional property configuration options you can pass in. In this case, we're basically passing in a config object with this extensions property saying that we want the viewer to load its standard viewer extensions, because some of the functionality in the viewer, like the sectioning and measure, is implemented as viewer extensions, and those are loaded by default. But by this piece of code, by this argument to the constructor, we're saying that we want the viewer to also load this other built-in extension called Autodesk.document browser. This one is not loaded by default, but we do want it there, and I'll explain why in a moment. So this is how you ask the constructor to add some additional viewer extensions when the viewer is being initialized. And then we simply start the viewer empty without any model just yet. And then we make a call to another method of a static class or static method of a class called Autodesk Viewing Document. And by that, we're basically asking the Forge model derivative service to give us some information about a specific model with a specific URN, right? This is the input, the first parameter we're passing to the load method. And the other two parameters are functions that should be called based on whether the operation was successful or whether it failed. So when the document.load function is successful, what we do is we find one of the outputs that were generated for this model. So remember, again, if it's, for example, a Revit model, the outputs could be, there could be multiple outputs for that, right? There could be multiple 2D sheets or multiple 3D views generated as part of processing that one Revit design. So this is a way for you to choose which model, which output from the Revit translation, for example, you want to choose. If a viewable ID parameter is defined, we find it. We find a view by that ID. Otherwise, we just get the default output, which is typically like the first or the default 3D view that's marked as default. And then finally, we call this method on the viewer object itself called load document node. And this is where actually we now say, hey, viewer, take this model in Forge and take this specific output that was created for that model and load it into the viewer. And that's it, right? And in case the document.load method fails, we just log an error into the console. And that is it. That's our complete client-side code. So let's give it a try. Let me run the app and head over to my browser. All right, let's head on to localhost 3000. All right, so you can see I'm already logged in. That is because earlier when we were testing our, when we were testing the endpoints, right, we already stored the cookies. Now we can try and reset that. I can just go to cookies and go to forge session. I can just take these two guys and delete them, right? So I just deleted all the cookies that our server app stored in my browser. So now if I reload the app, right, we made a request to our server. The server sent us an index.html, but now our JavaScript code tried requesting the public token for the viewer, and it returned, and it got an error. You may even see it here. I reload the page. See, so this is where, the browser asked our server for the index.html page. It started downloading all the dependencies defined in the head element of the HTML. And finally, when our forge tree JavaScript was loaded and the document was ready, the JavaScript code tried requesting the public token, but now we're not logged in. So the response was 401 unauthorized. And as a reaction to that, our client-side JavaScript realized, okay, the user, we received 401, that means that the user is not signed in yet. That's why it hid all the, the tree, it hid the logout button, it hid the refresh tree button, and it only presented us with this Autodesk sign in. So let's give that a try. What will happen now if we click on this button? We're basically just going to get redirected to the Autodesk servers, right? As we define in our server-side logic here. We're just going to be redirected to the Autodesk servers. Let's try that. So now, okay, the application is asking me to access for permission for my data and writing data, managing data. All right, I say I allow that. And now we're back to our local host, right? So the browser requested the local host of this index.html page. That worked. Again, that HTML page started downloading all the dependencies for jQuery, for Bootstrap, for Forge Viewer as well. Where is it? Oh, here, right? This is where we got the JavaScript for our Forge Viewer. And then when the document was ready, our client-side JavaScript code tried requesting an access token. And this time it returned 200 OK. So our client-side JavaScript code now knows that, okay, we received 200 OK. That means that the user is logged in already. Right, so then it hid the login dialog, and instead it now shows, our tree and the logout and refresh buttons. And that's it, right? So now what we see in the tree at the top level, that's the hubs, right? So in my case, I only have access to a single hub. Here it's called Petr Broz, but that's actually the Fusion team hub, right? If I expand it, I can see exactly the 4 projects that I saw in my Fusion team. And I can start browsing, the top folders of each project. And I can, drill deeper into the nested folders if there are any. But now this time you'll see, when I drill down to the actual files or designs or items, I still see these expand arrows there. That's because, again, since we're now working with the higher level data management, in that case, items, documents have their versions still, right? So if you want to open something, there might be multiple versions of your design. So that's why we present this extra layer or extra level of depth where you can actually choose which version of, let's say, my house design Revit model I want to open. And now when I click on it, we're just going to activate this logic in our Forge tree that we've defined on the tree plugin, right? By this, we added an event handler for an event called activate node. And again, we check if that node in its properties contains the URN of a model. And if it does, we're going to load it in the viewer. Maybe. Let's see. Oh, maybe some problems there. Unauthorized. Huh, interesting. Why would I get unauthorized? Robots. Ah, there we are. So we probably had an older version of the token, maybe the public token that we got in the cookies was maybe about to expire. All right, so that is it. That is our application, allowing me to browse my hubs and different applications built on top of Forge and previewing them in viewer directly. All right, that is it for today. That was our application. So now let's move on to questions first, and then it's going to be your turn. All right. There's a question. What is the tool you use to see the server responses? So if you meant the dev tools, let me start the app again. So again, it's probably going to be called slightly differently in different browsers, but every modern browser, like Chrome or Firefox or Safari or Edge, will have this kind of functionality. In Chrome, it's called DevTools. You can find it by going into these triple dots and more tools, developer tools, right? And this is where you can investigate all sorts of things in your web application. For example, you can use this Elements tab to explore the HTML, right? The DOM, the document object model. In other words, that's really the HTML markup that makes up your web page. What you can do is you can use this selection button to find an actual HTML element on the page and find it in the markup, right? So we see that this is the entire HTML. We see that this is the image. In the top left corner with our logo, we can manipulate the attributes here and try and make it larger. You can play with styling of the elements, right? So if I say, okay, so this maybe I want to add, I'm not sure. This image, maybe I want to give it a border, right? So you can change the styles here. Solid green, maybe, right? So you can play with the CSS styles during runtime, which I think is pretty awesome, right? So to change styles or the HTML markup, you can also use the console tab to see first of all, any outputs, logs or warnings or errors coming from your client-side JavaScript code. But what's even more exciting is you can interact with the viewer itself through here. So if you remember in our Forge viewer.js file, right, we defined that global variable called viewer. That variable, since it's defined in the global scope, it's actually available here as well. And now what we can do is, if we type viewer.dot, we're going to get IntelliSense, and we will see immediately all the functions, methods available on that object. So one of them could be get selection. If we call this, the viewer will tell us, okay, there's one thing selected and it has the ID 10, right? So that's the body of the robot. I can also go the other way around. I can say viewer.select.10. And by that, I'll basically programmatically ask the viewer to select an object in the model for me, like this. I can also do, for example, I can say viewer.fit2view, and that basically means move the camera to focus on some list of objects, or in my case, just a single object with the ID of 10, right? Which moves the camera to that element so that it fits the camera view, the viewport. All right. So I hope that answers that. And then, oh, sorry. And then the requests are actually typically handled in a tab called network, right? This is where you'll see all the back and forth communication between the browser and your server. So again, if I reload the page, you'll see in this network tab that we're capturing all the requests, all the request headers and everything, and also the responses and their headers, that of all the communication between our browser and the server, and also between our browser and other servers, right? So in this case, again, we made a request to our server with C. We already included some cookies, and the request was made to this URL HTTP localhost :3000, right? And the response to that said, it didn't say 200, it said 304, not modified. That's a, caching response saying, yes, this resource is valid and it hasn't changed since the last time you used it. So you can just use anything you have cached. And then the HTML started requesting additional JavaScript files from different origins, right? From CD and JS.cloudflare.com or from developer API Autodesk.com. And it also started requesting client-side assets from our localhost, right? Like in this case, from localhost JS4H3.js. So you can see all these requests and responses. And again, if I go further down, there was the, what was it called? Token request, right? So our JavaScript code in the browser made request to localhost API forge OAuth token. And the response to that was this. Or here for a better preview, right? So it actually responded with, the server responded with a JSON with two properties, with access token and expires in. So it says, here is your access token for the viewer, and it will expire in 3000 seconds. So that's one way to nicely explore, the HTML markup and the JavaScript objects on your page, as well as the communication between the browser and different servers. So I hope that answers that question. All right, there's another question: how to only show a specific project from the hub tree? That is really up to you, right? Because you are in control of generating that list of hubs, right? That is the part of our data management endpoint here, right? So what we do, if the ID parameter passed to our endpoint is empty or a hash sign, what we do is we just call get hubs and return it. We look at the get definition of that function. This is where we retrieve the entire list of all the hubs, right? And here, well, actually, you're asking about projects, right? So in this helper function, we're asking for all projects for a specific hub. So here, there's nothing preventing you from manipulating the resulting array in any way, right? You can filter these based on some parameters. You can say filter out only those projects that, I don't know, start with some prefix or that include some name in them, right? This is totally in your control. So before calling this res.json, before you actually send some kind of JSON back to the client, you can definitely modify this. So I can say, let's try a quick hack. I'm going to say data body data, right? That's the array that here we're basically running through the map function to change it to a different to a different shape for the JSON response. What I'm going to do is I'm going to type push 0. So basically what I'm doing here is I'm going to take the first element in the response from the list of all hubs, and I'm going to duplicate it, right? I'm going to push that same object from the array to the end of the array. So let's give that a try. So now, when I go back to my app and I reload it, I still see my hub, but you can see that now my demo project, oh, sorry, now this final project is duplicated, right? So you can, again, manipulate the responses that you send to, the JSONs that you send to your client in any way you want. You can filter stuff out, you can add stuff in. All right, and one more question. Yesterday we saw the model derivative API, which translates a model to SVF with the cloud credit consumption involved into this action. Each time we load, let's say, a Revit model stored in the Bin360 project, does it internally call to the model derivative API for the SVF translation with the same credit consumption? That's a very good question. Thank you for bringing it up. In case of Bin360 specifically, Bin360 does call the model, the same model derivative service logic internally for you automatically. This is really depends on the product. In case of Bin360, the designs are sent to model derivative service for processing as soon as they're uploaded, but they do not consume your cloud credits. This is because Bin360 as a product uses its own pricing model, right? And the translations are actually already covered by the Bin360 subscription. Now, however, be careful because other products like Fusion Team may not translate the files immediately. What I mean by that is that, again, this is a behavior that is controlled by the end products, right? So Bin360 starts the translation of your models into SVF as soon as you upload them. But in case of Fusion Team actually waits until you try and open the model for the first time, right? So it basically defers the translation until it's actually needed, right? So what could happen then is, right now, let's see if I could maybe try and reproduce it. What would happen if I went to Fusion Team and I uploaded some, let's say, Revit model to Fusion Team, and I didn't open it there. And then if I went back to my app and tried opening that design in my application, it wouldn't work because since I haven't opened the project in Fusion Team yet, Fusion Team did not translate it with the model derivative service just yet, right? So this is something to keep in mind. So no, it's not consuming cloud credits, but you need to be cautious about when these different products like Bin360 or ACC or Fusion Team, when they actually process your designs using the model derivative service. All right. You're welcome. It varies from product to product, but now we're talking about the Autodesk products built on top of Forge, right? So today, again, you have Fusion Team, you have Bin360, and now as a new addition, you have the Autodesk Construction Cloud, right? So these are products built on top of Forge, and these products may behave slightly differently when it comes to translating your models that you uploaded to them. All right, any other questions or comments? Oh, thank you. Is there a list for each product behavior or similar? That's a good question. I don't think so. I'm not sure if we have any documentation about how these products behave in terms of translating your files. Probably not. I mean, it's probably, I think it's as a recommended approach, what I would recommend is always checking, I mean, not assuming that a file that you're opening, whether it's in Bin360 or whether it's in Fusion team, or whether it's some file in your own bucket somewhere in the Forge data management service, always what you can do is you can check the manifests of that specific design in the Forge model derivative service. Let me show you what I mean by that. We go back to the portal documentation and we look at the documentation for the model derivative service. You'll see a couple of endpoints. These are basically the endpoints that Forge Viewer is using when you give it a URN, right? When you give it a URN and you call this viewer.loadDocument node, the viewer will try and go to these requests to try and start downloading the assets, the geometry, the textures, the property metadata, and all that stuff. And what you can do is actually to check beforehand whether that file is actually available for the viewer, is you can make a request to this get URN manifest endpoint, right? And when you do that, you can check, the status of the design in the model derivative service. Typically, it's likely that it's going to return, 200 OK, and it's going to return what would be a good example here? It's going to return a JSON looking like this, right? So, well, actually, this is a bad example. This one, right? So it's going to give you a JSON saying, yes, this file with this URN is already processed. I've been able to extract these kinds of derivatives, right? So I've been able to extract some property database. I've been able to extract some additional AEC data. I've been able to extract some 3D geometry or 3D view, right? I've been maybe it'll mention some 2D sheets as well. So this means, if you get this status success and progress complete in the JSON, that means, you're ready to go, right? You can launch the viewer and start opening the viewables, right? But it can also happen that the response is going to look like this. Small JSON saying status pending and progress 0% complete, right? So you can make this call beforehand to check if it makes sense to start the viewer at all, right? Because if you get this response, you can instead, in your UI, you can just show a message saying, translation is in progress, come back later. And similarly, it's also possible that maybe the design was successfully uploaded to Fusion Team or BIM 360, but the translation of it failed, right? So you could also, if you really want to be thorough and make your UI really clean and informative, you could also check that in case you get a response looking like this, status failed, right? In that case, you can look for some additional details about the failure, like message, right? And you can present that to your user instead of trying to start the viewer, which wouldn't make sense at that point. So I would probably say, I don't think it's documented the behavior of different products, but I would say never assume that the models are always successfully translated, right? It's I think a good practice to check beforehand before you try and initialize the viewer. All right, so I hope that answers your question. Yeah, let's see if there are any others. And if not, then again, now it's your turn to wrap up your cool Forge application for today. And again, as during day one, I will again go on mute and stop the video, but I will be around for another roughly half an hour. So if you have any final questions or if you run into any problems with this final step of tying everything together with the front end, drop me a note and I'll get back to you. All right, I see there was one more related to the previous. Could I monitor as I log the Forge API credit consumption or cost related to my app activity? I mean, is there some kind of value on the different API calls that gives us this consumption information, like the credits consumed because of a model translation? Yes, that's actually the final link in the nav bar on our Forge portal. So if you go to forge.autodesk.com, the final link you'll see in the top bar is called pricing. And that gives you, I think, a good enough explanation of the cost of the different services. If you scroll down to the Forge APIs and cloud credits. So you will see, for example, that specifically when talking about the model derivative service, right? A translation of a simple job, which basically means anything other than Revit or Navisworks, is going to consume 0.2 cloud credits per translation, right? And translation is a one-time cost. So as soon as your design file is converted into this SVF, for example, you can view that SVF using Forge Viewer as many times as you want without any additional cost. And then for Revit or Navisworks designs, these are more complex. So these cost 1.5 cloud credits per translation. And then similarly for some of the other services in Forge, like the reality capture or design automation. This is also different for AutoCAD and all the other design automation engines like 3D Studio, Inventor, or Revit. So these are charged cloud credits per processing hour, and the granularity goes down to, I believe, even like seconds, right? So if your job in design automation is running your, let's say, AutoCAD job is running for 15 minutes, you're going to be charged 1 credit, 1 cloud credit. And I think 1 cloud credit is roughly $1 if we want to translate it to the actual cost. And also one more thing I realized is you do have access to your usage analytics in your Forge account. So if I go to the top left avatar and I go to usage analytics, I'll see the different cloud credits consumed over time, right? For different applications. So you saw I had quite a lot of them, right? So you can check per Forge application your credit consumption over time. All right. One more question. Procedure-wise, what is the significant difference between model derivative and BIM 360? I'm not sure if I understand correctly procedure-wise. I think no, BIM 360 as a product, again, just to repeat what I was saying earlier, it does the same, model derivative processing of your files automatically for you, right? As we mentioned, you're not charged for these translations because these translations are already covered by the BIM 360 subscription itself. So when you go to BIM 360 product, I just noticed that you've run out of cloud credits. All right. So as soon as you upload your document to BIM 360 Docs, the BIM 360 Docs product will make a request to the model derivative service saying, hey, here's a new document, new design, please process it, right? That's the same thing. The same as during day one when we uploaded our own file to some bucket in Forge, and we also asked the model derivative service to translate that file for us. That's exactly the same process. All right. Do you use stubs in VS Code for Forge API? How to get that neat look of methods preview while coding? All right, let me take a look. If you are referring to the IntelliSense, like here, if I type projects and I get all this autocomplete here, this is actually, this is not, I don't think this is stubs in VS Code. This is simply JS code comments, and in some cases TypeScript. So this is just VS Code being quite smart in understanding, where those classes are coming from and what types of methods are available on classes, for example. So we can try and explore that here a little bit, right? So we're using this project's API class, and we're importing it from one of the third-party modules, right? That's the Forge APIs, the official Forge SDK. And VS Code knows where this is coming from, right? So if I hover that npm module name, see, it already knows that this is actually going to node modules somewhere. And now it's actually even smarter because this official Forge SDK is coming with TypeScript definition files as well, meaning it comes with sort of like an interface file explaining what are the different methods available on the classes, what kind of parameters they accept, what are the types of those parameters, and what types of return values they return, right? That's TypeScript is a whole another story here. But you can see that now VS Code could actually recognize that when we installed the Forge APIs module, npm dependency, it also came with this node modules add types Forge APIs. We can try and check if we find it in our node modules. So if we go to, oh, is there not add types? Oh, that's because it's going to be inside Forge APIs probably. For Forge APIs. All right, SRC, no. Oh, okay, so I don't see it here. So maybe it's actually getting it automatically. Maybe even cooler. Oh, it's actually, it's coming from my global library. So yes, so I think this is something I read about some time ago where VS Code may even try to automatically retrieve TypeScript definition files for npm modules that you install to your Node.js project. And I believe that's what happened here, right? So I installed Forge API's dependency to my Node.js project, and VS Code tried looking, oh, by the way, is there maybe somewhere a collection of TypeScript definition files for this npm module called Forge APIs? And it did find one, and that's why you get this additional neat typing, static typing, and IntelliSense, right? So again, if I let me see if that actually I say projects, yeah, and I say, for example, get which one? Get hub projects. You can even see that it says that the first parameter, hub ID, is a string, right? And it says that, so this should be some kind of string. And then the second one, it says that it's a JavaScript object that has an optional property called filter ID, an optional property called filter extension type, right? So you even see the types of the values that you should be passing into this call. So this is, again, all the goodies you get from TypeScript in conjunction with Visual Studio Code. And now you actually reminded me of one more thing, which I think is pretty neat, but that's a different project. But let me see if I can bring that one up. Oh, come on. Forge Basic app. So here's another neat trick. We tweeted about it some time ago, but the Visual Studio Code, you can actually, even when working on the client-side stuff, client-side JavaScript, right? So here, this is an app that I've been working on. It's similar to the app we built during day one. So I have some client-side JavaScript code that is, again, doing the same stuff as we do, right? It's calling Autodesk Viewing Initializer, it's instantiating the viewer, and it's calling, it's loading some specific model into the viewer, right? This is the standard Forge Viewer boilerplate. But check out this first line that I added here, this / import everything as Autodesk from add types Forge Viewer. So you saw earlier, right, that VS Code was automatically looking for some add types / Forge APIs, right? So somewhere out there, somewhere on GitHub, there is a large code base where people are submitting their TypeScript definitions for different npm modules and for different even client-side JavaScript libraries, including Forge Viewer. So in this basic app that I'm working on, I can actually just add this comment saying, oh, hey, by the way, VS Code, I'm going to be using some classes here in this client-side JavaScript code that are that are described in this add types for viewer npm module available somewhere on GitHub. And by doing that, here's what will happen. If I type viewer dot, I see all the methods and all the properties on the viewer object that are described in that add types TypeScript definition file for my viewer class, right? So I see all the, fit to view, explode, all the methods of the viewer object. If I type Autodesk dot, I will see all the, namespaces that are so viewing dot. I see all the different, types of events that are available under Autodesk viewing, document, or, any classes or enums, everything. Again, this is, I think, a pretty exciting, combination of the goodness of TypeScript and VS Code. So if you at any point want to, start developing your client-side, your client-side JavaScript code with Forge Viewer, try this line, this comment as well. We can actually see if we can bring that into our app that we've built today. Let's try that. I'm going to go to my Forge Viewer JavaScript file, and I'm going to add this comment, but I think I still need to go to my terminal, to my app, and I'm going to say npm install add types Forge Viewer. And I'm going to type not save, but I'm going to say --save dev. This is slightly different. That basically means that I want to include this dependency in my package.json file, but not as a dependency that is required to run the project, but as a dependency that is required to develop our Node.js project. And now let's give that a try. Oh, and you can already see the syntax highlighting is working here, right? So we've got our Forge Viewer JavaScript file now boosted with types. So if I go to viewer, oh, where am I here? I can again see a get selection method, which returns an array of numbers, right? So those are my IDs, and I can do something with them, and I can then say to view, right? And I see that, okay, this method expects an optional array of numbers. That's the IDs of the elements of my design that I want to focus on. All of that, now you get this perfect, beautiful IntelliSense and some static typing support for client-side JavaScript just with this one line of code. All right. Any other questions? You're welcome, Roman. Something in the chat. All right. Thank you, guys. Okay, so your turn now. And again, I'll stick around. Deepali and Cyril, thank you so much for helping me out today. You can go take some rests. I'll guard the fire. And yeah, thank you very much. Yeah, I'm looking forward to seeing you all tomorrow. I hope you all have registered for that session. That one's going to be joint. It's for both groups, for both Node.js and .NET groups. I'm going to be leading that one, and we're going to take any one of your projects that you've built during day 1 or 2, and we're going to move the focus to the client, where we're going to start enhancing and boosting up the viewer experience. All right, so let me stop the recording.